Video 2 on the 2018 Toyota Camry. So right now I'm hooked up to the pressures and I'm data logging it right now. As you can see, the high side is, I filled it on the high side with liquid with 650 grams or 610 grams on this vehicle. And it didn't quite go up to 88 on the low side because there's a resistance in this expansion valve holds it back. So I'm about to start it up and we're gonna watch this variable displacement compressor and see how the high side goes up, the low side goes out, and see what its limitations are. And we have 130,000 miles on the vehicle. Let's get, we're fresh air, high speed, maximum AC. We didn't start the vehicle yet. 1, 2, start, go. Okay, now let's go look out at the graft. The compressor should have kicked on by now. Yep. See the high side take off, and both the high and the low side almost simultaneously start leveling off and coming and changing at the exact same time. And we're driving for maximum cooling. And it's working. Oh, did we have a, yeah, we got a fan. The fan wasn't kicked. Fan just kicked on, and you'll see that. Still going up. The fan is on. You can see, you can see the fan. The fan is spinning. It's like 77 degrees out, so we're a little warmer today. And as it satisfies inside and starts bringing the temperature down lower, which we're at, oh, that's pressure. Let's go over the temperature. We're at 52 degrees right now. Let's data log that. And I cannot put up the window, so we're gonna do this test with the window open, and we're gonna do it under full load. I think we already got condensation building up on the pipes. Our temperature is at 50 degrees out the dash right now. Our inlet, okay, let's go back to pressures. Look at our superheat subcooling right there. We're at 11 degrees, 42. On a regular HVAC system, if this was a residential system, I'd say, hell man, you got that thing way overcharged. But this is not a regular standard HVAC or refrigeration system. This is a variable displacement compressor system. Don't try to compare the two. Not gonna work. All right, I'm gonna load the hell out of this. So the air temperature of the air, I believe, coming across the hood right now is 80 degrees. So I'm gonna take it off of recycle because it's a little cooler in here. Got the window open. We're gonna, come off of recycle. Oh, get it out of max. It won't let me. Now it will. There we go. Okay, so now I have the 80 degree air coming across the evaporator coil. Make sure that's all open all the way. Open all the way. Yep. Okay. Windows open. Fresh air. Go back to that. Let's go back to our pressure again. So as you can see, somewhere, oh, there's the hump, I guess, right there. is where I went from recycle the cooler air, and now I'm pulling in the 80 degree, 90 degree. So the air being pulled in right here off over the engine. The exhaust manifold, it's really hot here. It's 100 and some degrees. This is the exhaust manifold right down here. So that radiant heat and all this hot air, if you put your hand right here, you can feel this hot air being drawn right into the fresh air corral that is going down inside. So it's loading the evaporator, and that temperature is, that temperature is 90 degrees at that point. 57 degrees out the dash. And as you can see where I did the fresh, here was recycle air. Right there. It was 47 degrees. And right where you see this spike go up, that's where I hit the button on the inside, and I went from recycle air to outdoor fresh air. See the difference? And you can tell where I hit the recycle button, I went from recycle to fresh air. And you could see the difference as this was the recycle air. The interior cabin air duct dash temperature was continuously going lower and lower until that point where I hit the fresh air. Now it's starting to go up. And that's because the temperature of the air loading the evaporator. There's our superheat and subcooling. Look at our liquid line temperatures. So here's our actual temperatures. This is our suction line. You can see where I had it on recycle air for the cabin air. The temperature of the suction line coming back to the compressor was getting 48 degree refrigerant coming back to it. Then I hit the fresh air button. I loaded the evaporator. It used up all the refrigerant in the evaporator. It raised the temperature and pressure. Went up to 61 degrees, and now the compressor is moving because it's a variable displacement compressor. The speed is not changing. The compressor is stroking more so it can help bring back down the suction side pressure and control it to get the temperature down. Now we're back down in the 50s again, and this is because this is a variable displacement compressor. If this was a fixed piston compressor, you would see the high side temperature go up even more. But you see how rock solid, steady, that the line temperature, the liquid has not moved, almost nothing, within 1 degree. 90 degrees there to 91 degrees there. And as you can see, it has very tight control over the temperature out of the dash. Even though the temperature going into the evaporator has changed greatly, all the way from down from 87 degrees up to 109 degrees, we just have a slight up and down on the dash temperature. And that's because you don't have a clutch that's kicking in and out. Oh, and let's get this out of 134, get it back to YF. Always hitting the buttons and messing up my refrigerants. All right, that's it for this one, and I got to get off to the next one. I'll get you a video for tomorrow.